Hi, and welcome to the second part of SAT test. All right, so let's go through these questions together. I'm going to show you how you can solve these questions. Number one, John runs at different speeds as a part of training program. The graph shows his target heart rate at different times during his workout. On which interval is the target heart rate strictly increases when strictly decreasing. All right. So when it's increasing and then decreasing. All right. So A is between 0 and 30 minutes. So let's go to the 0 and 30 minutes. You see we have increase here and decrease here, and there's a constant here. All right. It's not strictly decreasing or strictly increasing. Between 40 and 60 minutes. So you see in this case, increase, decrease. So B is the answer. If y equal kx, where k is a constant and y is 24, when x is 6, what is the value of y when x is 5? So when x is 6, y is 24. So basically I can just plug in 24 instead of y equal k times 6. So from here, k will be 4. I divide both sides of the equation by 6. So when k is 4, we know k is constant. So k will be always 4. So our equation is now y equal 4x. Now when x is 5, I plug in 5 here, y will be 4 times 5, which is 20. Alright, next question. In the figure above, line L and M are parallel. Okay. And line S and T are parallel too, alright? If the measure of angle 1 is 35 degrees, so this is 35 degrees. What is the measure of angle 2? The one of the easiest questions. So we know when two lines are parallel, when one line intersect, this one and this one are equal, also equals with these ones. Okay. Now, here all of them are parallel, like these two are parallel with these two. So basically, if I just put another parallel line here, it means now this line that cutting these two parallel lines make the same angles here, also here, right? So when one is 35 degree, here is also 35 degree. So angle 2 will be 180 minus 35, which is going to be 145. This is the answer. If 16 plus 4x is 10 more than 14, what is the value of 8x? So 16 plus 4x is, so we always is equal 10 more than 14. So basically 10 plus 14. So from here I can find x. Basically we have 24 here, 16 plus 4x. Then I can subtract 60 from both sides. Then 4x will be 24 minus 16, which will be 8. Then x will be 2. X is 2. So what is 8x? X is 2. 8x gonna be 16. C is the answer. Number 5. Which of the following graphs best shows strong negative association between D and T? So when we have a scatter plot, we have two kind of association or correlation, positive and negative. Positive correlation is when x increases, y also increases. So it will be something like this. A negative correlation, on the other hand, is when x is increasing, y decreasing. So it's going to be something like this, right? So we need a strong negative association. D is the answer, right? It's going down. Why we do not choose A? Because it's not strong. It seems it has a correlation, it's negative, but it's not strong. Because the data are scattered, so our R squared value is not as strong as R squared value here. So it's probably going to give us something above 0.9, but here will be less. So long story short, if the data are compact, or like you can see that the dots are very close to each other, you're probably going to get a better, stronger correlation. All right. Next one. A hospital stores one type of medicine in 2 decagram containers. Based on the information given in the box above, how many 1 milligram doses are there in one 2 decagram container? All right. So 2 decagram container. So first of all, 2 decagram is equal to 20 grams. Why? Because 1 decagram is 10 grams. So 2 decagram is going to be 20 grams. Now, we want to know how many 1 milligram doses will be there. So we know we have 20 grams. Each gram is 1,000 milligrams. So 20 gram will be 20,000 milligrams, right? So there will be 20,000 1 milligram doses in the box. There we go. The number of rooftops with solar panel installations in 5 cities is shown in the graph above. If the total number of installations is 27,500, what is an appropriate label for the vertical axis of the graph? So we want to know if we add all of these up, right, the total number, it should be 27,500. So let's read the numbers on the graph. A is 9, B is 5, C is 6, D is 4, and E is 3.5. So adding all of them together, 9 plus 5 is 14, 14 plus 6 is 20, 20 plus 4 is 24, 24 plus 3.5 is 27.5. So we add them up and it becomes 27.5, but it needs to be 27,500. So basically these numbers are in thousands. Why? Because 27.5 times 1,000 is 27,500. So if these are in thousands, then the graph is correct. So the number of installations in thousands is the answer. For what value of n is absolute value of n minus 1 plus 1 equal to 0? Absolute value of n plus 1, n minus 1 plus 1 equals 0, then n minus 1 equal negative 1. Do you see any problem with this? The problem is an absolute value is equal to a negative number, which cannot happen. So there is no such value of n. The speed of a sound wave in the air depends on the air temperature. The formula above shows the relationship between A, the speed of a sound wave in feet per second, and T, the air temperature in degrees Fahrenheit. Alright, so A is speed, T is temperature. Which of the following expresses the air temperature in terms of the speed of a sound wave? So basically we need to solve for T and find out what is T in terms of A. In this case, we need to subtract both sides of that equation by 1052. So it's going to be A minus 1052 equals 1.08 T. Then divide both sides of the equation by 1.08. A minus 1052 over 1.08. So the answer is A. 10. At which of the following air temperatures will the speed of a sound wave be closest to 1,000 feet per second? So basically what you need to do is just plug in the speed and find T. So 1,000 will be equal to 1052 plus 1.08 t. So subtract 1052 from both sides of the equation. Gonna be negative 52 equals 1.08 t. T gonna be minus 52 over 1.08. Okay, so to find the answer, you need to use a calculator, and if you plug it into calculator, you will find out the answer is B.